In problem 5, we've got two types of tests we're going to do here. We're going to test first a mean and then a variance. And as we discussed in class, you do this frequently because you would want to know whether you're meeting both the specification for the mean and for the variance. We talked about temperature in a room or in a freezer. If it meets the spec on average but not the variance, you might not be very comfortable, or if it's in a freezer, your food might be thawing and freezing repeatedly if it's not within the variance spec. So these are tested together, and we're going to do this with a Fisher's office supply example here. We're given a couple of pieces of information here in the beginning. We've taken a sample mean of 2.15 hours. We have a sample variance of 0.35 hours. So remember, sample variance is s squared. We will have to take the square root of that to get s at one point here in our problem. All right, and so we have a random sample of 20 service calls. We want to see if they meet the spec of 2 hours or not. Our sample from the 20 that we took yielded a result of 2.15 hours with a variance of 0.33 hours. Okay, so we want to test with a significance level of 0.05. Here we have mu equals 2 hours, and mu does not equal 2 hours for our hypothesis statements right here. So it's a two-tail test, so we're going to have two rejection regions. So we're going to get two values for the critical value, a positive and a negative value. So let's take a look now here at our test, or at our student's t-table, and we have a two-tail test with alpha of 0.05, and we have a degrees of freedom is 19, 20 minus 1 is 19, and so we have our t of alpha is going to be 2.0930, or positive and negative 20930. Our decision rule is if the test stat is greater than 2.0930, point there, 30, or less than negative 2.0930, reject. Null, otherwise do not reject, as I scroll off the screen here. All right, so that's our decision rule, and now we would need to calculate the test statistic. All right, and to do that, we would use this equation right here. Let's make some more room for us and work on that right now. So we have x bar minus mu, and we know from the problem that we have for our test statistic is going to be 2.15 minus 2. 2 is from our hypothesis statements, right, of 2 hours or not equal to 2 hours. And then we're going to have s over the square root of n. Square root of n will be 20. Now, recall, here we have the sample variance of 0.33. To get s, we would need to take the square root of that value to get s. So to take the square root of 0.33, it's approximately 0.57. So that value is not given, at least obviously given in the problem. You have to remember to calculate that. So let's do that now. So we have this, the result of this 2.15 minus 2 over 0.57 over the square root of 20 is approximately 1.17. So our result then, t of alpha, 1.17, if we link back to our picture of this right here, it does not fall in the rejection region, it's between the rejection region. So therefore we would not reject the null. So that's the first part of our test. So far so good. In fact, we can even look at the last part of the question. We will reject or not reject the null hypothesis regarding the mean. We already know now, as a result of our test, we will not reject that. All right, so let's take a look now at the second part of the test, the one regarding the variance, or standard deviation. So I'm looking right here now. The standard regarding the standard deviation, which was expected to be a half an hour standard deviation, significance level of 0.05. Now, Our statements here are in terms of 0.25, and that's because we have to, the standard deviation is half an hour, 0.5, 0.5, and then the variance, of course, would be sigma squared. And so that would be 0.5 squared equals 0.25. So that's why you see that stated that way, because we're working with the variance in this test. So the decision rule, to get the decision rule for this test, we will need to work with the chi-square table. We have, once again, alpha of 0.05, degrees of freedom of 19. And our critical value, chi-squared of alpha, is 30.1435. So our decision rule is going to be if the test stat is greater than 30.1435, reject the null, otherwise do not reject, right? So that is our decision rule. To calculate our value here, we would to our test statistic value, we are going to use this equation here. Now here we have a little bit of another mismatch here. We have to remember which numbers we're working with. N minus 1, that's easy, I think. We say that's 19. S squared, right? That was given in the problem. Our variance is 0.33 over, and then now which do we use, 0.5 or 0.25? The variance is 0.5. Okay, so now we calculate that value, so we say 19 times 0.33 divided by 0.5, and I get 12.54. All right, so our test statistic, 12.54, is less than 30.1435, therefore do not reject. So let's go back to the problem here, answer that last part, and we would say we would not reject the null regarding the standard deviation. So what this all means when you bring it all together is that Fisher's is meeting the spec both for mean and for standard deviation on its service calls. I want to amend that last bit that we just did. It does not change the result of the problem, that we would not reject the null in both cases, but I made an error when I wrote this part of the problem right here. And you may have noticed that if you were still paying attention. We got 19 times 0.33, and it should have been over 0.25. I put 0.5. If you recall, it should have been 0.5 squared, which was 0.25. So it does change our result from 12.54, which I said, to actually it should be 19 times 0.33 divided by 0.25. It should be 25.08. So that is our true answer there. So my apologies for that. However, as I noted, that result is still not greater than 30.1435, so it does not change the result of our test.